Once, a severe drought struck William's village in Africa. There was no electricity in the village, otherwise they could have used a pump to extract groundwater. William was thinking about all this when he saw his teacher coming on a bicycle. There was a headlight on the bicycle. "Sir, there's no electricity in the village, so how do you charge the battery of this headlight?" "There's no battery in it. It has a dynamo, which converts the mechanical energy on the tire into electrical energy, and that's how the light turns on." "But how does current get generated from mechanical energy?" When William read his physics book, he learned that changing the magnetic field in a closed loop of a conductor causes electricity to flow in it. This is called electromagnetic induction. "But how does the magnetic field change in a dynamo?" "By the rotation of a magnet. The magnet of a dynamo rotates due to friction with the bicycle tire, which causes the magnetic field inside the loop to change. Sometimes the magnetic field increases and decreases in one direction, and sometimes in the opposite direction. Because of this change in the magnetic field, an AC voltage develops in the loop, and if many such loops are combined to form a coil, this voltage increases further." Using this same concept, William built a windmill from scrap materials, which started rotating a magnet inside a wire coil. William connected a bulb to the ends of the wires of these coils, and it started glowing. But he noticed that as soon as the bulb was connected, the speed of the windmill's rotation decreased. Why is this happening? Just like a bicycle, here the windmill is converting mechanical energy into electrical energy. As long as the generator circuit is not complete, only voltage develops in its coils, but no current flows. That means the mechanical energy does not convert into electrical energy. But as soon as a load is connected, current starts flowing in the generator, and according to Lenz's law, this current creates its own magnetic field that opposes the existing magnetic field. That means an opposing torque is now acting on the windmill, which is why it is rotating more slowly. "I'll connect a water pump to it." High-power equipment like a water pump requires more current, and this makes the opposing magnetic field even stronger. This means even more torque will now be required to rotate the windmill. So that means this generator will have to be driven by a much bigger windmill. Absolutely right. Seeing William's generator working, the villagers helped him build a large windmill. And now this big mill generated so much torque that the generator started producing enough current to run the pump. Maybe that's why electrical equipment is called load, because it puts a physical load on the generator.